In this video, we're going to talk about using generics in classes provided in the Java Standard Library. There are different ways to use generics. One, the sort of most basic, straightforward way is to use them as part of using the classes in the Java Standard Library, like list, array list, linked list, and so on. The other way to use generics is in your own classes that you write. So actually to create your own generic classes. We're not going to focus on that in this video. In this video, we're just going to introduce the ideas of using generics with the classes in the Java Standard Library. This is most likely something you've already done, even if perhaps you didn't realize that it was generics that you were using. So let's take a look at what this looks like. We're going to start by looking at the ArrayList API page. So you'll see here, this is the API page for ArrayList. It shows all of the methods and all of the information about ArrayList. But you'll notice that when it says class, it doesn't just say class ArrayList, it says class ArrayList, and then in the angle brackets, it says E. This E is a generic type. What a generic type does is it allows type information to vary. So what do we mean by that? Well, when you think about a method for a moment, think about writing a method, very simple method, for example, that took in a parameter and did something with that parameter, in this case, an integer n. What this parameter does is it allows the value of n to vary at different times when you invoke the method. So at one point I can invoke method with the value of 4, at another point I can invoke method with the value of 20, and at another time I can invoke method with the value of -7. So using a parameter here allows the value to vary, right? So inside my method I can, do whatever I'm going to do, okay? And this method will always work, but the value sent into n will vary. So parameters allow a value to vary, right? It allows us to invoke a method at different times with different values sent in. Generic type programming is a similar idea. The difference is that instead of a value varying, you're actually varying a type. So what this is saying is that we can create an array list that holds integers, or we can create an array list that holds strings. Or we can create an array list that holds student objects, or button objects, or bank account objects, or any other class that I want. The idea is that when the designers of the ArrayList class wrote this class, they didn't know what kind of objects you'd be putting in the list, and they didn't really care, right? They wrote all of the functionality of a list to work with any kind of object. If you are adding something to a list or removing something from a list, it doesn't really matter if you're removing a string or an integer, right? You want the list to function in the same way. So the ArrayList class does just that. It describes how an array list will function without specifying what will be held, what type of objects will be held inside that array list. So this generic type right here, which is E in the class, we use the placeholder value of E in array list. E stands for element. It basically, again, allows the type to vary. So it allows the user to say, I want to create an array list, and at this point in the program, I'm going to create an array list that holds numbers. At another point, I'm going to create an array list that holds strings. That type can vary. Okay? And that's the heart of what generics is. It's the functionality of letting type vary. Prior to using generics, you really most likely only saw values varying, again, through things like parameters. But with generics, the type can actually vary too. Because E represents a type, a generic type, but it's a type, you can use it anywhere that you would use a class, normally a class name. So that means that E can be used, for example, as a parameter type. So let's find an example here. So here is the set method in ArrayList. It allows you to set the element at a particular index to be a particular element. And here you can see that the parameter type of that second parameter is type E. So that means that parameter type is going to vary based on the generic type that's specified at any particular point in time. So if you create an array list that holds integers and you invoke set, the second parameter here is going to be an integer. If you create an array list that holds strings and invoke the set method, the second parameter there is going to be a string. So that type can vary based on the type you create when you create the array list. So we can use that generic type to be a parameter. It can also be a return type. So you'll see A couple different methods here that have E as the return type. So here, for example, is the get method. So if I invoke, get the element at index 0, if my array list holds integers, that's going to return to me an integer. And if my array list holds strings, it's going to return to me a string. If my array list holds bank accounts, it's going to return to me a bank account. So anywhere that you can normally use a class type, like string or integer or any other class, you can also use a generic class type, usually represented by T or E, for example, or other capital letters. And there is some naming conventions about the best way to name our generic types. And that's the basics of generics. They're pretty easy to use when you use them in the existing Java classes provided by the Java Standard Library. You just have to get used to what it looks like when you're looking at the API page. So when you come here, if you want to find out about the methods of the ArrayList class, you have to understand what this, angle bracket E means. Like, what is that? And hopefully this has given you an idea of what that means. It's just a way to vary, to allow the types to vary, to allow the user to vary the kinds of elements that you're putting into this array list. So now that we know that that's kind of what the E means, let's look at how we can actually use it in our own code. So we're going to look at a simple example here that's just going to create one method's going to create a list that reads in some user names from the user, and one method is going to read in some numbers, and we're going to use generics in an array list to do this. So let's start before looking at those methods just by looking at some basic examples of using generics. So if we were to create an array list without generics, if you create one of these collection type objects like list or array list or linked list without generics, it's called a raw version. So this would be a raw array list. So I'll call it my raw list. And if I do that, first of all, you'll notice that I do get a little warning here telling me that this is a raw type and that I shouldn't do this. In general, you shouldn't do this. When a class uses generic typing, you should provide a generic type. That's best practice. Generics were added to the Java language in, I think, Java version 5. So they've been around a long time, but they haven't been around since the beginning. So that's why you technically still do have the option of leaving off the generics, because they weren't kind of built into the language from the get-go. But just because that option is there does not mean you should use it. So you really shouldn't. Really, whenever you're using one of these generic classes, you should specify the generic type. But I just want to show you what it would look like if we didn't do that. So if we didn't use a generic type, we could just create this list called raw list. And because I don't specify the type of element that can go in the list, I can put anything I want in there. So I can add in a string. I can add in a number. I can add in a student. So I have a simple student class in the same directory that just takes in first name, last name, and student ID. Okay. I can add anything I want to this list because I haven't specified what kind of elements are allowed to be in the list. So Java will let me put anything in there. Of course, I have to get the syntax right as well. What am I missing here? There we go. Okay, and again, you'll see that these you're getting all these warnings because you really shouldn't do this. You should parameterize these types. So you should provide a generic typing when you create these objects. But again, this is what it looks like if you don't. What that also means is when I get something off the list, I have to cast it to the type that it's going to be. So let's say I wanted to get this first element off my list, and me as the programmer, I can see that that's a string. I still can't just say this, index 0, because the compiler doesn't know what type is at position 0. The compiler only knows that it's an object, right? We have not specified what kind of objects can be put in this array list. So as far as the compiler knows, it can be any kind of object. So even though as the programmer I can see that it's a string, I'm not going to be allowed to do this because the compiler doesn't know that. So what I'd have to do is I'd have to cast it like this. And now then I'm allowed to do that. The problem with that, of course, is that casts are very powerful and can be very easily misused. So I'd also be allowed to do this. and get the second element off the list and cast it to a string, even though it's not a string, right? And that's going to compile just fine because I'm allowed to cast anything I want to anything else pretty much. But when I run this program, it's going to crash with a runtime error because I'm trying to take off an integer and cast it to a string, and an integer isn't a string. Okay, so this is the problem with generics. It allows you to mistakenly add different types of elements to a list, and it forces you to cast elements when taking them off the list. So if, for example, this list really did contain all strings, and I knew that, let's say I know that, I'm not going to add any integers or students, I'm just adding all strings, I still have to cast them when taking them off the list, because even though I know that as the programmer, the compiler doesn't know that. So that's a big pain, right? We don't want to do that. So the solution to this is to use the generic typing. So what that means I can do is I can specify that this list, for example, is only going to hold string. So in order to use the generics, what I do is I put inside of angle brackets, I put the type that I want to use to instantiate this generic object. I put that inside the angle bracket. So inside these angle brackets, I put string or integer or student or whatever kind of object is going to go into that list. I put that on the declaration side. On the initialization side, I put it as well. Now, note that as of Java 7, you can actually leave the type off this right-hand side, which looks like that, but you do still have to include the angle brackets. So you'll see lots of people doing this. It's an option, again, starting in Java 7. I personally usually avoid doing that because I'm worried that if I leave off the type, I'll also forget the angle brackets, and this is actually incorrect. So to properly use generics, you do need the angle brackets, but then the type is optional. So you can include the name of the type a second time, or you can leave it off, but you definitely need those angle brackets. Okay, so I'm going to encourage you to get into the habit of using it on the right-hand side, at least until you're confident enough that you won't forget the angle brackets. So the right-hand side string is optional, the must be included, the angle brackets. Now that I've declared that this is, well, first of all, let's change this to a word list, since I'm saying this array list can only hold strings. I'm going to change the name. It's not raw anymore. So now that I've done that, you'll notice that now I have some compiler errors, because here I'm trying to add an integer onto a list that only holds strings, and it's not going to let me do that. So this is one of the main benefits of using generics, is that it puts a compile time check on type safety. Anytime you can push problems to the compile time, it's way better than dealing with them at runtime. Compile time errors are much easier to track down and find compared to runtime errors. That's not to say that all compile time errors are easy or simple, but anytime you can fix something at compile time versus a crash at runtime, much, much preferable to fix that compiler error rather than to try to debug once you get a runtime crash. So by using generics, I've put a compile time check to ensure, hey, I can only add strings to this list, and if I try to add something else, I'm going to get a compiler error. I'm not going to be allowed to do that anymore. Okay? But I am going to be allowed to add, any kind of string that I like. The other benefit is that now that the compiler knows that the only thing that can be added to this list is strings, I don't have to cast anymore to take things off the list. So I can just get an element off the list and put it in a string, and that's going to be allowed because the compiler knows, hey, this is going to be a string. You don't have to cast it. I know it's a string because that's what you've specified with the generic typing. So that's pretty much it for the basics of how you use generics with the classes of the Java Standard Library. You basically just, when you are faced with a class that gives you the option of generic typing, which you'll see from those angle brackets, followed by the placeholder for the type, it means that you will specify what type of object is going into that collection. When you do that, you'll put the type on the left-hand side and the angle brackets with or without the type on the right-hand side, and that's all you have to do. You then get the benefit of the compile time checks on adding only the appropriate types of elements into your collection, and you also no longer have to cast when you take things out of that collection or retrieve them from the collection. So let's just look at a couple more examples. So we're going to look at this method that reads in some usernames from the user, from the console. So I'm just going to create a scanner object, and I'm going to create a list that holds strings. And I'm just going to have a little loop here that tells the user, hey, enter names as long as you want, or quit when you're done. So every time the user enters in a name, as long as it's not quit, I'm going to add it to my list. And then when they're done, I'm going to sort that list of names, and I'm just going to print out each name in uppercase. Okay, so let's run this so you can see how it works. It's kind of a simple little method. And I'll just enter, Jessica, Jennifer, Jeffrey, and then I'll enter quit. And you'll notice that the list is sorted and the words are printed out in all caps. Okay. Now, the benefit of using generics here is that I am only allowed to add strings to this list. If I were to try to add, again, an integer, for example, I would get a compiler error. I'm not allowed to do that. I also am allowed to take things off the list or access elements in the list without needing to cast them. So I do that here where I'm iterating through each element of the list. And here I'm using the enhance for each loop, but you could also use a traditional for loop in the same way. It would look like this. So this would be the kind of version that uses a traditional for loop instead of an enhanced for loops. It's equivalent code to what we're using before. It'll accomplish the same thing, but you can notice that here you don't have to cast, right? Because the compiler knows what's coming out of there is going to be a string. Okay. If I hadn't used generics, first of all, I'm going to get all sorts of warnings because this is not good practice. The compiler is trying to tell us that, or I should say our IDE is trying to tell us this really isn't advised. You really shouldn't do this. But then we're also actually going to get a compiler error down here because we're trying to take something off the list and the compiler has no idea what type it is. So we're not allowed to do that. We actually would also not be allowed to use the enhance for each loop because this again assumes that every element on the list is a string, and we can't be sure of that if we are using the raw version. So we don't want to do that. So there is the use of generics with, again, strings. Let's look at one other method that's going to use a list using the generics to specify that our list is going to hold integers. So here we're just going to read in some numbers from the user and calculate the average. So I'm going to now create an array list that holds integers. So this is an array list. It's still an array list. But my previous array list held strings, and this one holds integers. So the class is the same. I'm using ArrayList, but before I was using it to hold strings, and now I'm using it to hold integers. The type that's held inside has been allowed to vary. I still have all the same functionality of an array list. I can put things on the list, I can take things off the list, but the type that's held in that list, I've been allowed to make vary, to make differ. And that's the power of generics right there. It allows the designers of the ArrayList class to just focus on what the ArrayList class should look like without having to worry about what kind of objects are held on it, because that doesn't really matter, right? When you're thinking about how to order things in a list and what the functionality is in terms of adding things to the front or the back or a specific position or sorting the list or things like that, it doesn't matter what the type is, right? All that functionality is just defined by ArrayList. So having the generic typing in there kind of strips that away and says, whoever wrote that class is just going to worry about the functionality of ArrayList. And then when the user of that class goes to use it, they can specify what type is held in this particular instance. And that could be a different type than is held by a different instance of ArrayList. So in this example now, I can ask the user how many numbers we're going to read in. I'll get that number from the user, and then I'm just going to use a for loop to read in that many numbers and add them to my list. Again, I'm allowed to add them here because I'm adding an integer to my list, and I've specified that this list can hold integers. One quick note here is that you'll see that I'm actually storing the user's number as an int, which is a primitive type, but because Java supports automatic conversion between int and integer or double and capital D double, between any primitive type and its corresponding object wrapper class, if you create a list that holds capital I integers, you are allowed to add ints to it. Okay, you can only use classes to specify a generic type, so I would not be allowed to do this. That is not allowed. You can't put primitive types here. You have to put a class. It's got to be a class. It can't be one of the 8 primitive types. So the workaround for that is you just use the wrapper class version. Each primitive type has one. And then with the auto boxing and auto unboxing, it's called, Java will allow you to add primitive values that behind the scenes get converted into the object version and put on the list. And subsequently, you can also take them off the list in the same way. So this allows me to put the numbers on the list. Then I'm going to calculate the total. So I'm just going to go through the list, summing up the total, and then I'll calculate the average and print it out. So this again is the enhanced for loop. But this time I'll use the traditional, I'll comment this one out and use the traditional just so you get a chance to see both. And let's, so I'm going to change my variable naming a little bit here to be a little bit better. I was a pretty terrible choice to begin with. So this is the same equivalent. This is the enhanced for loop, or it's also called the for each loop equivalent. But this is the traditional for loop version. Okay. You'll see here again that even though my number list holds capital I integers, I'm allowed to take something off that list and put it into the primitive type int. That's allowed because of auto boxing and auto unboxing. I'm allowed to automatically go between capital I integer and lower I int. I do not have to do this. That's not required. Okay, I could, but I don't have to, and I'm not going to. So just keep that in mind, and when you're using any of the primitive types, particularly int and double, but also char, things like that. So if you wanted to have a list of chars, you can't do this. That's not allowed because char is a primitive type, but you could use the object wrapper class character. Okay, so there is my code to get things, to access the elements from the list, and then I'll total them all up and print out the average. So let's run this, and I'm just going to skip the word part. How many numbers? Let's say I'll enter 4, 1, 2, 3, 4, and print out the average. Now, some of you might notice this average isn't correct. So what is the average of 1, 2, 3, and 4? It's 2.5. This is just a friendly reminder that anytime you are using division with integers, Java calculates integer division, meaning if the left operand and the right operand are ints, when the division is calculated, the decimal portion is truncated. It's cut off and ignored. So Java was here taking 10, our total, and dividing it by 4, our size, and getting the answer of 2.5. But because this is an int, the 0.5 was discarded, and the answer was just stored as 2. Now, even though the left-hand side is a double, that's not enough to get the right answer, because the way assignment statements work is that we calculate the right-hand side first, figure out that right side value first, and only then do we store it into the left. So what Java did is it calculated this right-hand side using integer division, getting the answer of 2, and then it stored it in a double, so it stored it as 2.0. The way to get the correct answer is we need to convert one or both of these operands to a double. And there's two kind of main ways to do that. One is we could multiply one of the operands by 1.0. That will, in this example, convert total to a double. And if either operand is a double, then it'll perform the kind of full correct mathematical division. The other way to do that conversion is with a cast. So I could also cast one of the operands to type double. You wouldn't have to use both. Either one would work. Okay, and now when we run this again, we'll get our correct average. So that's a little bit of an aside, nothing to do with generics, but it's just a friendly reminder because it's a super common error that I see, so I like to throw it in wherever I can. But anyhow, back to generics. That is an overview of how to use generics with the classes in the Java Standard Library. Key points here are how to actually use it just by putting the type inside the angle brackets. The benefits of using it are the compile time type safety that it supports, and also the removal of the need to use casting. You automatically know what kinds of objects are on the list, and you can automatically put those types of objects on and take them off with no need to cast. And so whenever you do have a class that uses generics, you should specify the generic type you want for that particular instance of that class.